Here's the agenda for today. I'm going to start with a little bit of a history lesson, just a little bit of a hello of what is noise. We're going to talk about grain on film, explain what that is, and then explain what digital noise is. And it's not necessarily, you don't need to understand all that to understand how to clean up noise, but I think it's just kind of interesting. So we're going to talk about it. And we're going to then look at some differences of DeepPRIME's noise reduction versus Lightroom Classic. Not to say that anybody is not good, but just to show you how incredible PhotoLab 4 really is. We're all used to the noise reduction tools that we have, and no matter what app you're using today, if you haven't seen the noise reduction in PhotoLab 4, I think you will be very, very surprised. So we're going to do some comparisons there. We're also going to talk about within PhotoLab the difference between the HQ/fast noise reduction, the prime noise reduction, which is what we've always had before, and then of course the new DeepPRIME. And in the case of doing that, we're going to talk about different types of photos, different use cases for it. Let's talk about noise, but to first talk about noise, I think it's helpful to talk about grain. So if you think about shooting film, for those of you, I realize some people may have never shot film before, but for those of you who have, you will remember that just like in cranking up the ISO on your digital camera, which results in a noisy image, if you loaded a high ISO film in your camera, you would get a grainier image. And it's interesting because the way that grain happens and the way that noise happens are completely and totally different, and yet somehow the end result is very similar, which is, I think that in itself is quite fascinating. But to understand film grain, you have to understand how film works. Film is a piece of celluloid with a photosensitive chemical, photosensitive salt, silver halides, salts that were on the film. You expose those to light and they change color, they get darker. Now, if you have a very low ISO film, the literal grains of salt, the silver halide grains, are very, very small. If you have a high ISO film, those grains are larger. Why larger grains? Well, think of it like a sponge. If you have a large sponge, it can soak up a lot more water than a small sponge. You take a large sponge and a small sponge, you stick them in water for a 250th of a second, like an exposure, or half a minute or whatever, you take them out. The small sponge can only soak up so much water, where the larger sponge can soak up a lot more. It's the same thing with film grain, with the silver halide grains of salt. The larger ones can absorb more light. So you can have a higher sensitive film, a film that will absorb more light more quickly than a lower ISO film with the smaller grain. So the side effect of that, of course, is you get big enough and those grains of salt become visible. Now, because they are literally organic items, they have that totally unique, totally organic look to them. Like a snowflake, no two grains are the same. And so when you look at a film negative or a print made from film and you're shooting at high ISO, that grain that you see is pleasing. Obviously, it can get to a point where it's distracting, it's too much, it doesn't always fit everything, but having that grain on there can actually be an aesthetically pleasing element. And of course, photographers, since high ISO film came out, have used that to their advantage. It's part of a look, it's part of how you shoot. And knowing that, you would go into a shoot where you have a high ISO, a low light situation where you therefore needed high ISO film, and you would plan for that. You know what you're shooting, and perhaps you're even going to shoot in black and white because that black and white high ISO film just looked really, really nice, versus high ISO color film. It's never really looked great. It was kind of okay, but high ISO black and white film looked gorgeous. So that's where the big grain comes from. Again, it's a physical, organic thing on the film. Now we move to digital. Digital, of course, it's not organic. It's not grains of salt on there. It is pixels. Now, if you think about your sensor, let's just say that your sensor is a 20 megapixel sensor. That is 20 million pixels. On the sensor, if you were to look at the sensor under a microscope, you would count out 20 million pixels, also called photo size. The pixel is really the word for it once it's on your screen. On the sensor itself, it's called a photo site. So 20 million of those. Now, we're not going to get into the differences between RGB and foveon sensors and all the different demosaicing and all that, where you have separate RGB. That's irrelevant for this discussion. If you really want to learn about that, please, I encourage you to spend some time in Wikipedia. The rabbit hole is deep. But essentially, for the purpose of this argument, of this discussion, you have a sensor that has 20 million or 30 million or however high resolution your sensor is, photosites. So those photosites are, of course, digital. The world around us is analog. So the light that we see around us, or don't see as the case may be, has to go through an analog to digital conversion to get to that photosite. So the process of doing that is step one of that process of taking the world around us and converting it to a digital image. But that digital sensor, that sensor that's made up of all these photosites, can capture light at its we'll call a native ISO, its native sensitivity. And depending on your camera, that native sensitivity could be higher or lower. Some cameras have a native sensitivity of 100 ISO, some have a 400 ISO. If you get into the world of video and film, then you'll find that you can even get sensors that have dual native ISOs, meaning that the ISOs are, meaning that the sensor looks equally good at, let's say, 400 ISO and 2500 ISO. It's simply how those photosites are tuned. Whenever you vary from that, whenever you increase the ISO or even decrease the ISO, you are going off of the native sensitivity of the sensor and of those photosites. And the process of changing that native sensitivity is called gain. You are gaining up or gaining down the sensitivity of the sensor. That process of gaining it up or down is effectively an amplifier. And if you think about it like a sound amplifier, a music amplifier, it is taking the existing signal. In our case, it is light that is being converted to a digital signal through this analog to digital conversion and amplifying it, making it louder, or making it louder is really a good way to think about it, because even a light wave is like a sound wave. It just makes it louder, it makes it bigger. The louder and bigger that gets, the more artifacting you end up with, the more judder, the more non-clean signal you get when it hits those photosites. And so as a result of that, by increasing the gain, you get to a point where you start to see artifacts from that showing up in the final image. And that is where digital noise comes in. Now, the reason that sensors are getting better and better over time, every year that goes on, we have higher ISO capable cameras where you can suddenly shoot it, where you used to be able to shoot it maybe 800 ISO, and at that point was the limit. You shot higher than that, the camera looked like rubbish. Today you get cameras where you can shoot at 25,000 ISO and it still looks unbelievably good, especially if you're used to shooting at the lower ISO rates, because those sensors are just getting better and better tuned to be able to amplify the image amplify the signal without creating artifacts or creating fewer artifacts. There's never none, it's just creating fewer of them. So anyway, so that's where this comes from. And so the process of removing noise, which is what we're going to be doing here, is there's only so much you can do with the original file that comes off. And you can't change what the camera has done to that file. But once you've got the data, the ability to look at the noise, for the software to look at the noise, analyze the brighter spots and the darker spots that make up noise. If you think about noise, if you zoom into it really close, you have darker and brighter spots. To be able to compare those values and decide what should be noise and what should be there, what should be a part of the image and what shouldn't be because it's noise, is where the software comes in. And the software that we're looking at today and that we've always looked at is just getting better and better at analyzing that noise, determining what is noise and getting rid of it. So with all that said, again, not important to understand how to get rid of noise, just kind of a point of interest here. So with all that said, there's a question that started to come up. Let me address this question and then we're going to jump into actually looking at the noise reduction. The first question comes up is why Prime and DeepPRIME only works with RAW files and not with DNG or TIFF files? That is a fantastic question. Also wouldn't work with JPEG. You have to have a RAW file to work with Prime or DeepPRIME. This has to do with how the denoising is done. To understand that, it's easier to talk first about how traditional denoising is done, where it is literally just an analysis of the image, looking at the image, and the software goes, okay, that's a bright spot next to a dark spot. That is probably noise because there's a whole bunch of stuff like this. Let's minimize that by maybe taking down the brightness, taking up the darker parts and trying to smooth that out, average those differences a little bit. That is at a very, very basic rudimentary level how it works. And in that case, you can do that on any image. Doesn't matter if it's TIFF or JPEG or RAW, whatever, you're just looking at the final result. What Prime and DeepPRIME are doing is they're not just looking at that pixel data. They're looking at a database that DxO has been building up for decades of camera and lens combinations by running a series of tests that they run in their labs. The full name of the company, DxO, is DxO PhotoLabs, and that's an important thing to realize. They have this huge lab in Paris or somewhere in France where they do countless tests with every camera and lens combination that they can get their hands on against a very controlled environment test chart at every single ISO and aperture combination possible to evaluate the incoming image. Once they build a database of all of the results, all of the differences between any sensor compared to other sensors and so on, then they can start to calculate what it would take to make this image look cleaner, look better, look sharper, remove chromatic aberration, all of those things that we don't want to see. But instead of just looking at the final image and saying, oh, that purple fringe shouldn't be there, that noise shouldn't be there, get rid of it, it goes all the way to the source of looking at the database, the comparison of raw files that they've been building up for decades, and comparing it to their knowledge that they've had for years and years of working with this. So because of that, you have to have the raw data to be able to do that analysis, and that is something that simply doesn't exist in any file that's been converted to TIFF or PNG or JPEG or anything else. It's also why you can't do this with scans. You can't scan an image and do a deep prime on it. It's never going to work. So that hopefully helps answer that question. Another question about what is the difference between DNG and a raw file? Leica produces DNG as its form of raw. Are you saying that this noise reduction won't work on DNG? So the last part of the question, I actually don't know, because I don't work with any cameras that shoot DNG. What DNG is it's a wrapper for raw data that Adobe came out with quite a while ago as a universal raw format where the camera still shoots its own proprietary raw file, but then it's put inside of a DNG wrapper. This digital negative is what it stands for. The idea behind it being that you have this universal format that will always live, and you never have to worry about your raw converter no longer supporting your raw file format. That's the idea behind it. Why cameras like Leica choose to shoot to DNG, I don't know. I'm not a Leica shooter, and I've never really dug that deep into it. I think that, and Lori, maybe you can chime in here. I think that DeepPRIME will work on DNG just like raw files, but once again, they have to be supported. It has to be a file format that DxO has analyzed, but I don't actually know. One way you could determine that is to look at the compatibility list on DxO's website that shows what cameras are supported by DxO Raw and therefore DeepPRIME, and see if those Leica cameras are listed there. If it's not, then maybe that's the answer, is that it doesn't work. But anyway, so that's what DNG effectively is, and I don't know why certain cameras, and it's very few, but why some cameras do choose to do that. Okay, all right, so if you've seen some of my DxO demos before, you've probably seen some of these same images. I chose to use the same images for this reason, because you have likely seen these before. When we compare them to what you get in Lightroom, this is going to be even more of a surprise. So first of all, let's just talk about how DeepPRIME works and how denoising works in PhotoLab, just in case you haven't seen this before. This photo here, actually I'll just reset this. I'm going to start from scratch. This photo here is a raw file. If we look at the metadata on here, where are we? Let me reset my workspace here. Go to advanced workspace, here we go. If we look at the metadata on this file, we'll see that this is a 25,000 ISO image, so it's quite high. I'm actually, sorry, I'm gonna turn off my camera at this point just to make sure that there's plenty of room to see my screen. So this image is shot at 25,000 ISO, so it's very high ISO. It is also shot on a Lumix GX8, which is a micro four thirds sensor, so it's quite a small sensor, which high ISO plus small sensor is really a terrible combination. If we look at this photo one-to-one, you'll see, let me go to my denoising, make sure that everything is reset here. Yep, you can see there is it's quite a lot going on here, quite a lot of noise happening here. It doesn't look super awful, but we can see it's quite rough around the edges in here. The overall image is quite flat. And if I press the compare button here and we compare it to the original raw file, then we truly see how much noise there is. Now, I always like to point out that this view is kind of unfair to show you because no software will ever show you this view by default. This is with all denoising turned off. All raw decoders do a level of denoising by default. It's just a part of the raw decoding process. So this is what we would just consider a standard look of the image at this ISO. If we really want to see the pure raw file, then that's what we're looking at. But I only show this to really drive the point home of just how far it's come from coming out of the camera to what we're seeing by default. Now let me do a little bit of light adjustment on here because this image is quite flat. So I'm just going to do a quick little bit of curves adjustment here. Let me zoom out of this just so we're, zoom out of this so we're seeing the whole thing. Just to add a little bit more contrast, a little more saturation, and there. So it looks dramatically better already. But let's zoom in close. And again, we're looking at the tiger's face in here. And I'm going to go to the noise reduction tools in here. And you'll see up here you have DxO denoising technologies, and there's 3 different types. There's the HQ, also known as the fast denoising, which is the real-time denoiser. Then there's prime and deep prime. Now both prime and deep prime, it's very important to understand that these do not get applied to the whole image here in the preview. As I turn on one of these, and I'll turn it on in a moment, but as I turn these on, we are not going to see the whole image update. This process is so intensive that it will only happen on export. At some point, as computers get faster and faster, maybe that'll become a real-time process, but for now it is not. And I'm going to grab this preview window and put it over the eye because it's a good point to see what's really happening in here. And that loads that preview into this small window here. So now we're seeing the same part of the image. And at this point, because we're in HQ mode, we're seeing the same image. But now as I turn on prime, you'll notice here, even there, it takes a moment to render out that small piece of it. Now we're seeing the prime denoise. And if we toggle back and forth between HQ and prime, you can see the difference. Now it updates in real time because it's already cached that. And you can see how much better it looks. And this is prime. This is what we've always had in PhotoLab. But then we get into deep prime. And deep prime is where it gets so much better. Now at this point, as I toggle back and forth between prime and deep prime, notice the fur, the little dark specks in the fur here. That's the first thing I want to bring your attention to. And you can see just how much more detail is there. That's the first thing we're looking at. Second, I want you to look at the edge of the eye and see how smooth it is here, but how rough it is here. This is all part of that deep prime machine learning, artificial intelligence algorithm that has gone into this, that has looked at literally millions and millions of photos and learned what photos are supposed to look like. It has learned that this curvature in here is supposed to be smooth, and it has smoothed it out. If you look at the original image, here we're seeing all of that texture in there. And in fact, let's just do this. Let me zoom in a whole bunch more to this, and you can really see in here, it's not that the eye is rough, it's simply that the digital noise is so coarse in here, so dramatic, that by the time you smooth it out, you end up with something that even under regular prime looks textured and smooth. But when we go to deep prime, it has figured out how to round that out, smooth it out, and make it look really, really pure. Now, because of this, again, because we're seeing it just in the preview here, if we do want to see it over the whole image, we do need to export it. Now, PhotoLab, if you haven't seen this before, has a cool feature where we can export to the same folder as the original, and it'll show up right next to it. And then there's a feature where we can easily toggle back and forth between them. So I'm going to do that now. I've got this image selected. I've done my curves adjustment. I've set it to deep prime. I'm going to go to the export dialog. Let's see, it's set to standard output as a JPEG at 100% quality. Folder is set to the original image folder. So this is the part that will allow me to do the side by side, and I'm not doing any resizing or anything else. So I'll click on export. Now I want to point out that this process on a mere mortal computer could take 30 seconds, could take a minute, could even take a couple of minutes if you're on an older computer. This has taken a matter of seconds. It says here it took 8 seconds to do, but I am also doing this on a very high-end Mac Pro. So it's a little bit of, so it's almost smoke and mirrors how fast this is, but that's just because this computer is so incredibly fast. But if you don't see these kind of results, don't worry. It's not normal to see those kinds of results in there. Okay, so now I've got 2 versions. There's the raw. Next to it is the JPEG, and I can click on that to load it up, and we see how much more details in here. But just before we spend too much time on that, I'm going to go back to the original, and then under the view menu, so actually before I even do that, if I click on compare here, it is now going to show me a comparison back to the original photo. We've already seen that. If I go to the view menu, I can set the reference image as my output image. And now when I do a compare, I'm seeing a difference between the non-prime, so the standard HQ denoising, and the prime denoising. It's just kind of a cool tool that we have in here so you can easily toggle back and forth. So with this on, with this image loaded, look at the fur down here. Look at how much cleaner and how much more detail there is in the fur in there. Let me do the toggle back and forth again. You see the amount of detail in the fur on the tiger's mane. Look at the whiskers and how much cleaner they are in the DeepPRIME version. Again, the detail on the nose, the fur in the nose in there, it's absolutely remarkable. Just to remind you, this is a 25,000 ISO image shot on a micro four thirds sensor, and it looks this good. So that is what DeepPRIME does. It has this algorithm. We'll talk a little bit more about the algorithm in a minute, but it has this algorithm that it does to do this incredible denoising, but you only see it on export. So now let's do a little comparison. I'm going to bring up Lightroom, and let's start with the same photo. Where are we? Here we go. And develop, and let's do a full reset on this. And we're going to zoom into 100%. And let me do a little bit of window rearranging in here. Let's say I'm going to collapse this, and I can't quite do a 50-50 split on them just because of the resolution I'm running my screens at. I won't quite fit, but if we do this, we can see a pretty good comparison. Okay, so now we're looking at Lightroom here. Let me do this similar type of a curve on here just to give that kind of contrast back into it and the saturation. So do a quick little S curve in there, make that look similar to what we saw in the other photo. Of course, we're not comparing colors here, so don't worry about that. But now let's zoom into 100%. Let's go to the detail tab for our denoising. And you'll see under detail here, you have sharpening, both sharpening and noise reduction. Noise reduction is off by default. Again, there is a level of denoising that is part of the raw decode process. We're not seeing that in here. This is a secondary denoising, which is what this is, a secondary denoising. And it's currently turned off. So now let's just go back and compare the HQ image, the original HQ images. I kind of wish that the colors were a little bit more similar, but oh well, it is what it is. This is, well, this is no additional noise reduction. So let's see if we can get the noise reduction in Lightroom to kind of match what we're getting in PhotoLab in the HQ mode. And I would say, I think that's pretty close right there. Again, ignoring the color differences, but looking at the noise, I think that's a pretty fair, even comparison. So see, I put the noise up to 35 on here, and over here we're at standard HQ or fast denoising. Okay, so that looks pretty even there. All right, now let's take this up. Let's see how much better we can get. Now, I will give Adobe some serious credit here. This is totally real time. As I'm dragging this back and forth, we are seeing this in real time. Again, yes, very powerful machine, but we don't have to wait until export to see the results on the whole image. But as you can very clearly see, as I start to drag this up, we really start to lose detail very quickly. Let me take it all the way up to 100. At this point, this is obviously massively over noise reduced, but you can see the smoothness in the image in here and just how soft and smooth all the little bits and pieces are. We've lost all the detail, but we've also lost all the noise. This is what noise reduction is doing. It is smoothing everything out to make sure that, smoothing everything out to hide or eliminate as much noise as possible. But you get to a point of, let's call it diminishing returns, where you just lose too much detail. And it's always a compromise. You know, how much noise reduction do I want to do versus how much detail am I willing to get rid of? And if I look at this photo and I drag this back and forth, I would say right about there maybe would be the absolute most that I'd be willing to do. We can see, if you look at the nose is a good area to see because it's quite a flat area. We can really see the noise in there, and you know, smooth it out a fair amount, and it's looking pretty smooth in there. But look at the fur. It's just a mush, right? It is an absolute mush in here. So if I want to back this off to bring some of that fur back, well, now we're starting to get a lot of noise back in here. Maybe you think, well, I can compensate for this with sharpening. A little bit you can, but what happens is, in fact, let me just bring the smoothing way up. As I start to increase the sharpness, you notice that, let's zoom in even closer here, you start to see the noise just reappear. It just kind of reappears in the image in here as I bring that sharpening way up. And so you're really not doing yourself any favors whatsoever by doing that. Let's bring this back down to, let's see, I need to open this up to get to a 100% view. There we go. Okay, so again, with my luminance slider dragged as high as I'm comfortable bringing it, we're going to say right about there, and I've definitely sacrificed some sharpness. But now let's go back over here to PhotoLab and let's look at that DeepPRIME output image. And now look at the difference between them. The smoothness of reduction of noise is still greater on the left. We're still seeing more noise on the right. But more importantly than that, because I can live with a little bit of noise, more importantly than that is the level of detail. Look at let's start with the black specks on the nose. You can see all those lovely little specks here. They're just gone here. Look at the eye. The eye is nice and smooth in here. I'll give it that. It has definitely gone nice and smooth in there, but we're still seeing a lot of noise in there. And then we start looking at the fur, and look at the fur here. Look at it's just a big mush, whereas over here you have all this detail. Look at the fur down here on the mane compared to this. An incredible, incredible amount of detail difference. So this is the difference. This is what we get when we compare PhotoLab 4's DeepPRIME denoising compared to what you get out of Lightroom. And what you're going to get out of other apps is going to be very, very similar to this, whether you're looking at Capture One or you're looking even at Topaz's quite advanced noise reduction. This is still going to be dramatically better. So let's look at a couple other images, because I would just want to show it's not just this photo. Let's do this one next. So this is a singer at a bar somewhere, and this was shot at also at 25,000 ISO. This is an Olympus M5, so also micro four thirds, even older sensor than the GX8 that we had up earlier. And again, 25,000 ISO. Here's the native image looking at it in PhotoLab with the HQ noise reduction. And you can see, well, let's look at the original just because it's fun to see just how bad it was. But you can see in here, there's some color splotching on her skin. There is a lot of roughness. There's still a lot of noise, a lot of roughness along the edges in here. And overall, obviously, this doesn't look great. Okay, same photo over here. Well, the color differences are really dramatic, aren't they? Same photo over here. Let's just make sure this is reset. Let's do a reset. Yes, it is. And this is our default state without any noise reduction, but let's take the noise reduction up to 35, 40 or so it matches what we did before. And I think at this point, it's comparable. I think we're looking at roughly the same amount of noise, same amount of maintained detail between the two images. Okay, cool. All right, now let's go back to PhotoLab. Let's turn on DeepPRIME. Let me go ahead and I'm just going to export this. Let's just get it up full screen. I'll do the same thing as I did before, where it exports out to the same folder. We're going to see this load up next to it in just a few moments. Again, that one only took 5 seconds to export. Phenomenal. And pull that up, and it's kind of incredible. And then let's go back to this photo and let's take that noise reduction up. And let's just do it until the skin on the right looks as smooth as the skin on the left. How's that sound? Let's just look at the skin only. I would say, let's say right about there. I think that looks comparable. So we're at 70 noise reduction on the right in Lightroom. I think the skin looks comparably smooth, but now look at the details. Look at her eye. I mean, her eye's almost gone. It's almost completely obliterated here, full detail. Look at the top of her head. Look at the hair coming off the top of her head. It's a mush, there's detail. Look at, oh, this is a great one. Look at the hair on the edge of her head here that's just hidden by this little rim light. Compared to over here, it's like a watercolor smear. It is just a remarkable difference in there. See what, oh, here's another good one. Let's look at the hair here again. On the left, you see the hair that's poking out from behind her hand. Tons and tons of detail in there. On the right, it is just a big ol' mush. And if I take the noise reduction down to the point where we get some of that detail, well, you can't. I mean, look, if I take the noise reduction all the way down, okay, at 0, you might argue there's that detail there, but there's so much noise you can't use this for anything. So we add a little bit of noise reduction, and immediately we start losing a ton of detail in there. One more sample photo, one more. And then I see there's a couple questions coming up. We'll hit those next. Let's go for this one. I love this photo because it is, let's see again, let's check. I'm pretty sure this is also the EM5. Yes, it is also 25,000 ISO. So again, old micro four thirds, 25,000 ISO. And let's take a look at this. Let's go into 100%. And again, here we're just in HQ mode. Look at, let me just make this bigger for now. Look at the labels on the bottles here. Look at how much or how little, depending on your point of view, of the text on here you can read. It is, some of the larger words are readable, the smaller ones are virtually not readable. There's a ton of detail missing. The wood in here has virtually no texture. It's just, it's all gone. Okay, DeepPRIME, export, use the same preset, just drop it out to the disk. Let's see how fast this one goes. Let's see if we can beat our 5-second time limit, time before, another 5 seconds, excellent. And pull up this JPEG, and now look at the difference there. I mean, that's just incredible. Look at the detail like in the glass bottle here. The texture on the bottle, this is texture, I don't know what you'd call it. Anyway, it's kind of like not engraving, but molded, I guess, into the glass in there. You look at the denoised one, or the original one, I should say, and it's just a mush. You look at the DeepPRIME, and there's a ton of detail brought back into it. You can read words that you could not read before. This is just truly, truly remarkable. Okay, now let's compare this to Lightroom. Let's get the same photo up here. Let's get to the same view. Where were we? Yep, right about there. And again, I'll take my denoising up. We'll start at the default position. Let's go to around 3540 on there. Let's actually go back to the raw in here and set it back to HQ. So here we're seeing the difference of the standard denoising. And I think again here we can see they're very, very similar. We're seeing a similar amount of denoising happening, similar amount of lost detail, but we're now going to jump back to that DeepPRIME JPEG and take the noise reduction up. Let's see, what can we use as a comparison? Let's look at the blank space behind the bottles in here on the wall. So I want to try and match that level of smoothness. To do that, as I bring this up, we're going to get pretty high. Again, similar to the other image, we're around 75, 80 before it gets to that smooth point. And you can see this is just a big watercolor mush. So fine, let's back it down a little bit. Let's try and find something that looks better. And I would say, I'm going to say right around there, around 50 is probably as high as I'm going to want to go. And again, the difference in the detail here is absolutely remarkable. Look at this label. Look at the detail on the label here versus here. Look at the wood. Look at the texture you can see in the wood. The texture you can't see, oops, the texture that you can't see here. It is a huge, huge difference. Okay, all that said, let's take a quick look at the questions that have come up. I see there's a few of them. And then we'll go to the last part of this. Okay, should you start with processing noise first, or it doesn't matter? It doesn't matter. That's a cool thing about how this works. It literally does not matter. You might choose to make some tweaks to it. You have a small amount of adjustments that you can do to the DeepPRIME, although there really isn't much. If you go to, let's go back to the raw, you go to DeepPRIME, it initially looks like you only have, DeepPRIME, it initially looks like you only have a luminance adjustment in here. But there's actually a little bit more. There's this tiny little plus down here, and it's quite hidden because honestly, there's really hardly any reason to go in there. But you also have a dead pixels slider adjustment. You would really, I've never come across an image where I need to use this. If you find an image that has so many stuck pixels or dead pixels on it that the standard DeepPRIME is not finding them and eliminating them, then open this up and increase that threshold. But otherwise, it's the only real slider you have in here is luminance, which again, I would almost never change. I showed this off before. If I go look at the wood on here, and we watch this preview up here, as I bring up the luminance, let's take it up all the way, you'll see that it does start to take on that watercolory look. We can see that up here in the preview. So again, the default value of 40 is most likely going to be perfect for you, but you have a little bit of adjustment in here to play with. But to go back to the original question of, does it matter if you do this before or after anything else? It does not. It absolutely does not. You can do it whenever you want to. It's especially driven home, that point is especially driven home by the fact that this doesn't actually even get applied until it's exported. So if you set this from HQ to DeepPRIME, it's not going to affect your performance when you're working on the image at all because it's not actually applying that. So it really literally does not matter when you do it. Just don't forget to do it if you are going to apply DeepPRIME. Next question. So if Lightroom is where your catalog is, when you bring an image into PhotoLab 4, I believe it changes from RAW. Am I correct? If so, what do you do? Okay, excuse me. Yes, if you are in Lightroom and you just do an export out, then it will convert it. But I think, let me see here, plugin extras. Yeah, there is this option here. There's this plugin extras transfer to PhotoLab 4, and I'm pretty sure this does it as a RAW. Let me see here. I'm going to hide my screen for just a moment. Just going to pause it, and because I don't have much in this Lightroom library. See if I can find something else that's not already over in PhotoLab, and we can test that out. Let's see here, make sure this is a raw photo to begin with. Okay, I'm going to go and share my screen again. Here we go. Where am I? I'm lost. Where am I looking? Here, metadata. Yeah, CR2. Okay, this is a raw file. So this file is raw. Let's take this photo and let's just do it from the file menu, file, plugin extras, transfer to PhotoLab. I'm pretty sure this takes over the raw image. Yes, it does. Yeah, so this has brought over the raw. You see it down here, .cr2. It even is now downloading the DxO Optics module for that photo. So we process that and away we go. So yeah, that's how you do it. If you want to bring the raw file over, you go to File, Plugin Extras, Transfer to DxO PhotoLab. If you don't see that, then reinstall PhotoLab. When you installed PhotoLab, it should have popped up a dialog that said, do you want to install the plugins for, and it just scans your library or scans your hard drive and it looks for appropriate apps. In this case, it would be Lightroom Classic. I think Capture One. I think Capture One has something similar. Could be wrong on that. But anyway, that's what you're looking for. Next question, is there any situation where Prime will be a better choice than DeepPRIME? Why do I need Prime if DeepPRIME is superior? Okay, great question. I'm gonna say no, there's no situation where it would be better. I could be wrong. There might be some random photo that for whatever reason, DeepPRIME just doesn't work. I've never come across this. I'm sure that the folks at DxO have done a bajillion hours of testing on this and they haven't come across it. Theoretically, it's possible, but let's just assume that it's, let's just say it's not. So why would you use regular Prime over DeepPRIME? DeepPRIME does take longer to export. So if I go back to my photo, let's go back to PhotoLab and let's go back to the photos that I was working with before. Oh, bravo, I don't even know where those were. Let's see here. Here we go. I think this is them. Yeah, here we go. So let's go to one of those same photos. And we'll do this one again. We'll do the same picture here. And if I go to, see, we already exported this, right? And it took, is that the last one I did? Yeah, that was the last one. It took 5 seconds. So this might be hard to tell on this machine because the machine is so fast, but let's do a standard Prime export and let's see how much faster it is. Export that, use unique names, and oh my God, it's taking longer. Well, that's interesting. Fascinating, Watson. Absolutely fascinating. I can't believe that took longer. Very, very surprising indeed. I absolutely thought that it was slower. Maybe that's this machine. So, okay, here's what I'm going to say. Do your tests. If you've got images that don't need DeepPRIME, like you want good denoising, but it doesn't quite need DeepPRIME, run some tests on yours. If regular Prime is faster on your system, then you can use that. I think the only time it would really matter time-wise, and when we're talking a couple seconds difference here, the only time it really matters if you're exporting a huge batch of images. So let's say you've got 100 wedding photos that you're going to export. They were all shot indoors in the dance party, and they weren't shot such high ISO that DeepPRIME's critical. If a Prime export time difference makes a difference, then go for it if the results are good enough. But I think for the most part, you're just going to want to go for full DeepPRIME. So to the final part of that question is, why is it even there? Why not just get rid of it entirely? I think it's a couple things, and I'm speaking for myself, or I'm not speaking for DxO, but I think that the reason this would be there is because of compatibility, just to ensure compatibility, just in case there's any weird things where it doesn't work, but also a legacy. If you have an image that you have worked on and you have fine-tuned and looks perfect with Prime, and then you apply DeepPRIME and you don't like the way that works, you need to be able to go back to regular Prime. You don't want to have a situation where you open up a photo and the photo no longer looks the way it used to. And after you spent all this time working on it, it no longer looks the way it used to. So I think in general, it's a very good idea when a software company does something this big. It's kind of like a raw decoder version in Lightroom. You can go back to older raw decode versions if you need to. I think it's the same thing here. Okay, in Lightroom Classic, in Lightroom Classic, you use the luminance slider to reduce noise, but not in DxO, right? Do you use the luminance slider in DxO? And if so, can you show the effects? Well, we saw that, and I think that question came up before I saw that. I did drag the slider in there. We saw that it does absolutely have an effect. And let's go back into the DeepPRIME and reposition this and do it again in here. And we can absolutely see a difference in there, but it is substantially less of a difference than we saw in Lightroom. So here with it all the way at 0, we are effectively seeing think at 0 we are saying the same thing as HQ. Well, no, that's not true either. But we are saying a much less denoise. If we take it all the way up to 100, it gets overdone. It gets that watercolory look. You absolutely can play with this and adjust it, and if you want to try and get a little bit more out of the software. But that 40 point, that midpoint starting point, is the prime, no pun intended, place to be. I think it's worth pointing out that in traditional denoising, remember that there is no analysis of the image. There's no, now that's not a fair thing to say. There's no deep analysis, let's call it that way, of the image. And so the luminance slider setting of 40 is going to affect any other image relatively the same way. Whereas here in PhotoLab, that DeepPRIME is looking more at the core of the image, at the raw data and so on, to pull up all that history of all the information that's ever happened before, part of that whole deep learning, which we're going to talk about in a moment. And it's less valuable, less necessary to adjust the luminance slider. It's kind of a half answer, but hopefully that helps. You can adjust it. Honestly, I've never needed to. Oh, here we've got also, it showed up in the chat, in my chat. I don't know if this has come to you, so I'm going to drop this into the chat for you. I'm sure that you've already got it, but I'm dropping it in anyway. Oh, it has. Lori's already dropped this in. So in your chat, if you look at that now, there's a list of supported cameras and lenses I mentioned before, if you want to check and see if your camera is supported. And that would be a place to find out if the DNG is totally not supported or not. Again, Lori, if you know and you want to drop that into my text and let me know if DNG is simply not supported at all, or if it's just particular cameras, just like RAW, that'd be great. Okay, let's see here. We got all those questions. Okay, so now let's talk about the last part of this. And I'm going to leave my camera on because this is not a demo as much as a discussion. I'm going to bring up a web page just to talk about the DeepPRIME part of this a little bit more. And I'm also going to drop this link into the chat. This is just on the DxO website, but this talks about what DeepPRIME is and how it works. And you know, I'm no scientist. I'm not going to get like really deep into the weeds because I can't on how this whole thing works. But I kind of touched on this in the beginning as well. It's important to appreciate that what we're seeing with DeepPRIME is not just looking at the pixels. It is going way, way beyond that. It is an artificial intelligence. It is the culmination of literally millions of photos that have been analyzed and taught the AI how to denoise. And if we scroll down on this page, it's kind of interesting. There's this illustration here that talks about the process of what DeepPRIME is, this artificial intelligence, aka machine learning, deep learning, lots of different names for it in here. But points out here, millions of images analyzed by DxO over 15 years. And it is, again, not just the photo, but it's not just, oh, we know this about the camera and the lens. It is all the testing that DxO PhotoLabs has done over all these years, I guess it's 15 years, where they've been comparing all of these cameras and really truly understanding what goes into any particular camera and sensor. One of the things that has always been said by DxO about PhotoLab is, well, if you're a professional photographer or working with professional gear, at least, that you can always make your images look better in PhotoLab, right? Absolutely, that's part of the thing of PhotoLab. You just get the best out of your raw images. But if you're working with lower end gear, let's say on Canon, for example, you've got your L glass, which is your really high end professional expensive glass, and then you have your non-L, which is, it's just not as good, right? It's still a great lens, but it's just not as good. When you take that non-L lens shot photo and run it in through PhotoLab, they are doing things to that image that most raw decoders are not doing, because they understand it's not just a generic interpretation. They understand this lens that you had on there has, let's say, a little bit of chromatic aberration at this focal length and at this aperture. You see a little bit of chromatic aberration show up. They know that. So they look at the raw photo, and this goes back to the earlier question about why does this only work on RAW, because the raw photo has all this data. They look back at it and go, okay, well, it was shot at this focal length. You know, let's say it was 100 to 300 zoom lens. It was shot at 202 millimeter, and it was shot at this focal distance, and it was shot at f11. And with that data, they can go back in the database and go, well, with our tests at near that focal length, at that aperture, and so on, we found purple fringing in the top left corner. And so then they know to analyze and look for that and to reduce it. This is all part of what goes into that raw decoding, and that is part of what feeds into this DeepPRIME technology, this AI that is combining all of that data, the analysis of millions of images to give you that. So that's kind of Again, not very scientific, but it's a high-level overview of what DeepPRIME is. Regular Prime has it has the analysis of the years of history of camera models and lenses, but it doesn't have the millions of images that have been fed into the algorithm to teach it how to denoise. And it's important too to think that it's not just about, oh, there's noise on it, right? Like it knows the difference between skin tones and the flat defocus, like on this sample photo here, the flat out of focus green areas of the shrubbery behind it versus the feathers on the falcon. It knows the difference between those, and it knows how to treat different parts of it differently. It recognizes the hair, it recognizes skin, and it treats them differently. That's all part of the AI that is in there. Okay, let's see here. Files you can work on. I need to make this bigger. I'm going blind here. There we go. Files you can work on in DxO PhotoLab support the following formats: raw files from cameras supported by the software. So again, you can look at that that list. DNG files from cameras supported by the software. Okay, so DNG is supported just with specific cameras, just like raw. DNG files created by DxO PhotoLab, so you can generate you can generate DNG files and process those. DNG files created by Adobe Lightroom, Camera Raw, and DNG Converter, with the exception of lossy compressed DNG format and DNG files resulting from merging HDR panorama and panoramic HDR from Lightroom. Oh, that's a fair assessment, right? Because if you do a panoramic merge in Lightroom with raw files, you can output a DNG file that is no longer considered a raw file to PhotoLab. And then you can still work on JPEGs and other formats, but of course you're not going to get the DeepPRIME on that. Okay, cool. There you go. Great. Thank you very, very much, Lori, for dropping that in there. There's another question that come up. So you can do batches that will apply the same changes across all the images, say for Star Trails photos. Batches will apply all the same changes. So, okay, so if I'm understanding the question, if you have a series of adjustments that you want to apply to the same adjustments to multiple images, yeah, you have copy and paste adjustments in PhotoLab. So let me pull this back up. My screen's still on. Yeah. If I, this is a good example here. Let's just say that I've got this photo here and I turn on DeepPRIME. I don't need to, it's a low ISO image, but let's say that I do. And I do some curves on here. And let's make it really obvious by doing let's do a black and white conversion. Here we go, just do a black and white. So now I've done all these adjustments. If I want to apply these to a bunch of other images, it's not that I apply them on export. I apply them here, copy and paste the adjustments here in PhotoLab, and then when I export, they all get applied. So I would go in here and right click and choose copy correction settings, and then choose the other images that I want, right click, and I can paste correction settings, which is going to paste everything. But I can also say paste selected corrections, which would allow me to disable certain things like, oh, I don't want to apply the tone curve to the rest of these. So I'll turn that off, hit paste, and now it's going to apply the black and white without the tone curve or any other adjustment. So that's how you do that. And then once you've done that, you'd select all of these and export all of them at once. Would DeepPRIME give a different result if you used a different test area? Oh, great question. Does the location of the test area influence the overall result? That's a really good question. Absolutely not. This test area that you're seeing here, what he's talking, or she is asking is, wait, where'd my mouse go? Hello, mouse, there we go. Is this preview window up here? Come back, there we go. This preview window here, does where you put this matter to the final output? Absolutely not. The whole image is analyzed when the DeepPRIME is applied. This is purely for your enjoyment, for you to go through and see how it's going to apply to different areas. So this is where I might look at this and decide, oh, I want a little bit more increased luminance on there. And look, if I go, well, actually, it turns out if I increase the luminance too much there, then I get mushy here, so I'm going to back it off. This is not about applying a different amount of luminance to different parts of the image. It is just previewing different parts of the image. One day, machines will be fast enough, and who knows, maybe with this transition to Apple Silicon, at least on the Mac, maybe this will get fast enough. I have no idea, but we are still, even on a machine as powerful as my Mac Pro, we are requiring processing time to preview that, which is why we don't see it on the whole thing, and we're limited to just that preview window. Okay, that's it, folks. Oh, there was another one came in. Is DeepPRIME to be used on all images or only those images with high ISO? Another great question. Only on images with high ISO. There's no benefit to applying it to a low ISO image. You're welcome to try it, give it a try and see. but you are not going to see any difference. Let's take a look at it. Let's go to this photo here. Let me reset this. And let's do a close-up look on his face. So let's just first see, oh, this isn't, so let's work on this, because this is an adapted lens. It is going to work. Okay. I just realized this photo was shot with an adapted lens, so I didn't know if it was going to work or not. Sorry, that's not where I want to be. I want to look at the metadata on this photo. Okay, this is an ISO of 200 on a Lumix S1, full frame, very low ISO, and I mean that looks really clean in there, right? That looks really clean. If I toggle between HQ and DeepPRIME, I'm seeing no difference whatsoever, none whatsoever, as I would expect. So unless you have that high ISO noise, there's no benefit to it. I'm curious now. Okay, I'm going to test this now just because I don't know. If I set it to HQ and I export this, let's see how long that takes. Let's just call this suffix is HQ, export. I do like that we get a timer down here that shows how long it took. Okay, so now I'm going to do that same image in DeepPRIME, export it again, DeepPRIME, and see how long that takes. Okay, so it is, and it's still analyzing the image. It's just taking time to analyze the image, and it took just as much time as the other ones to do, but the end result is not going to be any noticeable difference. Let's zoom into 100%, and oops, go JPEG. There we go. Oh, did I do the wrong one? No, that's right. Okay, there's the HQ, and there's the prime. Yeah, there is absolutely no difference whatsoever that I can see, which I would expect again because there is no noise in this image. It's a super, super clean image. Okay, with that, ladies and gentlemen, we're signing off. Thanks a bunch for tuning in today. I hope you enjoyed, appreciated, and learned a thing or two. Take care, have a great weekend or great week, and I will see you next week because we're doing another one of these in just a week's time. Bye.